Okay, in this class, I'll be talking about implementing a singly linear linked list. So, what is a linked list? We can take, you can see the schematic view of some linked lists. Okay, here, how many linked lists can you see?
Four.
There are 4 linked lists. And in terms of the structure, what we can define? What is a linked list? What is a linked list? So each of these yellow ones, each of these yellow ones are a linked list, right? Now, what each linked list, how can we define a linked list? What it consists of?
Nodes.
So linked list is to be more specific, linked list is a collection of, it's a linked collection of nodes. Is that fine?
Yes, sir.
So a linked list, as you can see, a linked list is a linked collection of, is a collection of nodes linked to each other. Now, if the number of links is 1, we can call it as a singly linear linked list. If they are having 2 links connecting to the nodes of similar type, we can call it doubly linked list, like that. So now if I talk in terms of object oriented terminology, how many objects you can see here? How many distinct objects you can see here?
So node objects or linked list objects?
Now that is so I didn't specify it, so that's why I'm asking. So how many objects, if I just ask how many objects you can see here? I mean,
Sir, 4. Sir,
yes.
4.
So is 4 a complete answer? Now I can say that, so as you can see, these yellow ones, they have got some kind of similarity, probably, because you understand linked list. But if I say that, if I look into each linked list, what it consists of? It consists of some distinct or easily identifiable boxes, right? So these are boxes. So we can say that these green ones, you see, each of these green objects, so now can you say what it, so how many objects are there? How many objects are there in this design or in this particular diagram, in this whole of it? Hmm?
10.
How many? How many identifiable objects are there?
10, sir.
I'm not getting. How many?
10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that enough? Can't
So
we say that these
14.
yellow ones are also objects?
So 14.
Right? So how many identifiable objects? We must say that 14 objects. I mean, you can go on identifying these integers also objects, right? Because these are also something uh, that is distinctive. But let us assume that these integers are all there and we don't have to take care of uh, creating integer objects. So 14 objects are, I think, good enough, out of which 10 objects are of type 10 objects are of node type, like these boxes, right? 10 such objects and 4 objects which are of these yellow color types, right? So these are yellow colored objects and this these 10 are these boxes. If I look into that, if I talk about the design, so are they same? Are these two same? The way they look like, these green ones and these yellow ones, are they same? How they are related?
So no.
Hmm?
The yellow one is made up of green ones.
Yellow one is made up of green ones. So let us say that these are, so let us say these are node objects, right? These are node objects and these are linked list objects. So there are 4 linked lists. To be specific, there are 4 linked lists, 4 linked list objects, and there are 10 node objects uh, within them. So the first task as a C++ designer is to identify objects, then try to find out which objects are of similar type. Now we found that these objects are of similar type, these objects. So and it is also that how they are related. Now we can say that linked list class, I mean linked list object type, or this, and there is a node object. How they are related? Linked list. So linked lists, they have nodes. They has a node object, or they has many node objects. Can we say that?
Yes, sir.
So this linked list class. So there are two classes because we find two distinguishable category of objects out of this 14 that we have identified, and for each we have to write a class because it is not supported by the original C++ compiler. You don't have a class that represents a node and all this. So the next thing is, are they dependent or are they I mean kind of related to each other? The answer is yes. So linked list, a linked list, it has a number of nodes. Okay, so if I would like to, so to write this code, so how many classes do I need to define?
So two.
Two classes. One is the linked list class. Let us call it as SLL because we are talking about single linked list, and this is let us call it as node, right? So we have to basically write two class definitions, SLL and node. Now the next question is, uh, what a node should contain? What a node should contain?
So
Data.
data and pointer.
So any node, as you look into, you see it must contain this part, right? So something as here and here. So let us assume that this is integers that we store here, and these are, and what is this field? I am trying to define what? I am trying to define a node class. So I am trying to define a node class. So if this is a node object, so if this is an object belonging to node class, so there is a pointer which will be pointing to another such box. Okay, so this is definitely going to be a pointer field, the second one, which will be pointing to some other node objects, right? That's the case. So the first one is this and second one is this. Is that fine? If you look into any node object, it has got an integer value and it has got a pointer value. Pointer to whom? Pointer to objects of same class type, because they are all belonging to node class. All these green ones belong to the node class, objects of node class. Now I am trying to come up with a definition of this node class, or what members it will be there. So what I find is, if I look into even in the minimal form, I find here there is an integer field, there is an integer member, there is a pointer member. Pointer to whom? So pointer to pointer to whom? Pointer to nodes of same type in the node definition. Okay, so this is how can I figure out? So how many data members will be there in the node class?
1.
How many data members should be there? Hello?
So 2, sir.
2.
Let us assume that we have got one more just to have it for use, maybe in some other purposes, because we are going to use this node definition in writing linked list class, and which may be used in some other developing some applications. So let us call it as extra. Okay, we will name it as extra also. So this is also a kind of integer field. Okay, so there is so let us assume that we have got two integer fields and one pointer to node field. Okay, so this is, so we got the outline of what the node class members should be. Now what will be the interface of the node class? The members of this node class is fine. So what will be the interface? Interface means, what the interface means? The methods, the method interface. What do you think? If you write a class, you have to, at least what you need to do?
So constructor.
You have to construct and you have to destroy. So there should be something like node and this. What else do you need? Do you need to have any other interface for this particular class to manipulate the class objects? Hello?
Sir, insertion and deletion.
Now, but will it be done in isolation? That is my question. Do you have a single node object created and within that you are trying to insert and delete? Will you ever use this node object? Will you ever use this node object, a object of this node class type, in isolation? Do you think so?
Sir.
So, because node is just a part, cars or bikes. Now you went to a shop and then you bought an engine. So is that enough? So can you just use the engine to drive it? It's not possible, right? You have to buy a car. So an engine or maybe a wheel, it's of no use, right? So these are useful only if they are used uh, if something else is composed of them. So they are always kind of parts which are used to develop some other data structures. So the node structure is also something like that. This is a structure, or this is a kind of component, or in other words, an object of a node class is a component which should be a part of some other class objects. Say for example, in this case it is a linked list object. Is that fine? Got my intuition?
Yes, sir.
So
Yes, sir.
hello. So that is the reason probably we don't have any we don't include any other methods in this, except you can have a display function. Okay, so display why? Because after you have constructed, you may be willing to see whether the contents through which I have constructed is correct or not. I mean, you just have to, you just want to check that whether this class works fine or not. That's all. Okay. So let us, so this is one part. So what will be the interface here? So this definitely is void. Destroying the node is void. That's fine. So I'll come to it. So what is the other one? It is the linked list class, SLL class. So node class, and these are SLL class. Okay. So in the SLL class, what do you think? What should be the members of the SLL class? You said that SLL class is composed of those boxes, right? Now you are trying to construct a linked list object. In a linked list object, when you construct a linked list object, what you should include there?
So
Think
node
of the
class.
case. You are constructing a linked list object. So when it is just constructed, it's like a newborn baby. So what it should contain?
Head pointer.
Hmm?
Node pointer.
So as per the design here, we have considered that every linked list will come up with a head node. It's not a pointer, it's a head node, right? This is also a node, same as these other nodes. But this is a special node, which probably what it stores in its integer field, the count of the nodes, count of the elements of that linked list, right? 3. Here it is 2. Here it is 0. Here it is 1. So whenever you think of creating a linked list, I mean, it's just after creation, what you should expect? The linked list should be, I mean, when it is just born, a linked list object is born. So what it should contain during its birth?
Number of nodes.
No, I don't have nodes. So you have nothing. So when a baby is born, there is no roll number, there is no Aadhaar card number and nothing. So it's a newborn. So in this case, a newly created linked list object, what it should contain? It should contain
Single head node.
a single head node. That's the point. So you should rather ask the question something like this: that what is a minimal way of defining a linked list? What is the minimal? So you cannot define it if you scrap things from that. Okay, so a baby when is born, 2 hands, 2 legs, and all these. So these are minimal things, and then after that, with time it grows and then it acquires more things and all. That is fine. So the minimal thing, when you define, you should define with the minimal one, and then later on it will have other additional burden. It will. So as human beings, we acquire things from the earth. So it's like that. So in the definition of a class, of a simply linked list class, how should it look like? The minimal design, it's a head node, right? And it should be pointing to whom? The head node should be pointing to,
Null.
So right now null.
it should be null. I mean, so in other words, when we construct, it should be something like this. So that is what the constructor should do. But so if I now define how many members should be there in the single linked list class, how many members? How many members should I have to define? How many data members while defining a linked list? As per the design that we have discussed, there can be many other ways also. As per the discussion,
So we need a member variable or node.
so we should declare. So what should be the declaration? So first of all, how many member data? How many members? Data members?
So at least one of
At
node.
least one. So I am talking about the least one. So at least one. What should be the type of it?
So node.
Is it a node pointer or node? Is just a node object?
So node pointer.
Why should I use a node pointer? Even if I create a node pointer, that node pointer should be pointing to the node head, right? The head node. So why can't I just declare? Why can't I just define a node object itself? Why should I need a pointer and then the pointer should point to allocated node? Why should I do this? Because I know in any case, even in the minimal form, one head node should be there, right? Are you getting my point?
Yes, sir.
So instead of having a pointer defined, which will be pointing to the head node, because a head node will anyway be there after the creation. So I can just say that, okay, let me have the head node. That's all. So I would like to have a head node object, directly a head node object. That is as simple as that, right? And probably I don't need anything else as data members. So here there are, maybe in this case there are 3 members, and in this case there will be 1 member, right? Is that fine? In this definition, 1 member, and that is how it will look like. It will be, say, I can call it as head, the name, and the head should be of type, what should I write?
Node.
Just node, that's all. So that means during creation it will allocate space for one box, that's all, and that will be the head box, and initially it will be 0, this will be null. That is what I mean. So probably within this you have to, during the construction you have to basically take care of this, because the space is already allocated. So this you don't have to dynamically allocate the space within the constructor of this class. You just have to assign the initial values to it, that's all. Is that fine? Now what will be the interface here? This SLL class interface, we should have SLL, we should have destructors, we should have, what else we can think of? We can have display, we can
Insert.
hmm?
Delete.
We can have
Say
insert in the,
insertion and
so add beginning, you can have several types of adding. So add beginning, we can have search, we can have delete, uh, delete some node, whatever I specify here. And okay, this may be the, just a minute, sorry. Okay, so this is done. Now the next question is, like, whether these members, I mean, what should be the type definition, I mean, access specifiers of these members. There are 3 members, like 2 integers and 1 node pointer. So will they be declared as private or public? What do you think? Are you getting my question? So these 3, and here this is 1. So what will be the access right of this defined for these members? Do I make it private?
Private.
Any other answer?
sir, data member should be public because we need the option for changing the data.
Where you should need the where you should be changing the values?
Sir, for the node class, for example, if we want to change the value of a particular node, so
Yes, so
we
you see,
require.
right now who told me that it is private? So if you make it private, you see, if you make it private, that means any changes, any updation or access to these values can be done only via the member methods of this class, right? Are you getting me?
Yes, sir.
But the thing is, once you declare a head node or any other nodes which will be linked, so here in the constructor you say that in the constructor I will be assigning 0 here and this. So this head node is fine, but the members of the head node, do you have any of the members which are meant as public, so that you can change and modify it here from here? Are you getting the point? Are you getting the design issue here?
Yes, sir.
See, so anything that you make private will be accessible only through the class methods, through the methods of this class, right? But here you are trying to say that this linked list class is composed of such objects. And once it is composed of, you are trying to manipulate, access, and modify such boxes. So if the contents of the boxes, if the box is sealed, if the contents or the components of the boxes you have made under locked, so it is locked completely, so there is no point of having the boxes, right? Because these are the linked list objects, linked list methods, which will be actually accessing, modifying the methods, modifying the fields of this, right? So what should be this case? They need to be,
Public.
and they all need to be public, because sometimes you have to change the link. If it is if you are adding a new box to this box, you have to store these box addresses here. Okay, if you want to say access the value in the information part, you have to do that. And this extra also probably will be used somewhere in some other time. So all of them need to be public. So this is public. So
Sir,
this is also public. This is also public. Do you agree? And what about this member? This member, which is a head, which is a box denoted as head, or it's a box, statically allocated box. Do I make it public or private?
So public, sir.
Do I really need to make it public? Is it compulsory? Hello? I can make it public, but if I make it public, what will happen? Any other classes or even from the main, I can get into the linked list and I can modify the contents of this head, this portion, right? The head count, the count of the nodes, and then the whole thing gets messed up, right? So I would like to have, I would like to provide an interface to the single linked list or the linked list object to the users in such a way that if they want to use the linked list object to add something, to display, to search, to delete, they can always do it using the interface that I have given. But they should not, and it is not required also that they directly jump into the info part of the head and modify it, or maybe they just make the link part of the head as null. If the link part is made null forcefully, what is going to happen? The linked list, hello, if the linked
So we
list
can
head
lose
has
all
got a
the
chain of nodes
connections.
connected, so you cannot reach the rest of the nodes that you have, that is a part of the linked list, right? So these things are possible, and it is not maybe malicious purpose, but maybe by mistake also sometimes you can do that. Hmm. Okay, please give me 5 minutes time. I have to scan the answer copies. I'll come back. Maybe 3 to 4 minutes. Hello.
Yes, sir.
yes.
Meanwhile, you try to think about the interface here. Interface here. Interface means the number of arguments that you need to pass. Just I'll take 3 4 minutes.